Hey everyone, today we're going to do a video on this wood, this kind of parametric wall that someone's created out of these wooden poles. It's woodwork by Gerhard Mayer. Found it on this Instagram page, parametric.architecture. It's really nice. I followed them. They're really cool. I don't know why I didn't like it, but I guess I did. But anyways, yeah. Usually I just find my precedents through here or other places as well. So please follow them. Yeah, I follow them. So yeah, follow them. Um, and yeah, so I'm going to create this. Sorry, sorry, my throat's a little hurting. So something that I found interesting about this one in particular is that there's so many ways you could make this, but I think the way I'm going to approach it right now is I'm going to approach it using a bunch of points and use those points, a field of points to create this type of what's it called? This extrusion. Yep. So, and something interesting also is that it's the patterning of these poles are checkered or kind of like honeycombed in a sense. As you can see, they're very checkered. They're not gridded. They're in a checkered pattern. So it's something I found very interesting. So the way I'm going to approach this is I'm going to make a field of points, and then with those field of points create an extrusion with these wooden poles. So yeah, let's get that started. I'm just going to move this to the side. I apologize. Yep, and I did make this about a few hours ago. So I did make the not answer key, but I already attempted making it, and I did make it. So I'm just going to not repeat everything. I'm going to do some things a little differently because there were definitely some inefficiencies in the script that I made. So anyway, so we're going to start with a square actually. I think that's the best idea. I'm going to start with a square. And I know that this wall, where is it? This wall is an approximately like a 1 to 2 proportion. So like this side is double the size of this, or this side is half of this. So if I divided the length of this by 2, it would equal this. Oh, why is that equal this? So I'm going to keep it at that proportion. It's approximate. It's not exact, but so type in 0, and I am going to plug this in. It's red because you see it says canvas is less than 1. That's fine. So all I do now is just do a division in order to create this to always be fit within this geometry. So as you can see, when I do this, it'll always be in that 1 to 2 proportion. So, and I'm also going to keep these numbers, this number even. Do I want even? Yeah, divide by 2. And this number has to be even as well. So 66, 68 should be even, right? Yep. Alright, I'm actually going to keep it at 80. Where 80 is a good number. And that will create a steady amount of points. So we can now type in points. And what this will do now is create a field of points. There already were a field of points, but now it's highlighted through this. So what we're going to do now is we're going to do basically an attractor point. An attractor point. So I know that I need to at least create 4 attractor points. One here, one here, one here, and one here. So I'm going to start with this one right here, the one that's going in the negative direction in the sense that we think about it in the XY coordinate. So let's get started with that one. So we'll just type in move. So this is basically the attractor point lesson. Also, I learned that if you want to move something, you just hold Alt and then click, and then it'll separate it, which is pretty cool. So if I wanted more room here, I would do that. I just found that really cool. So let's do what's it called? I want in the Z direction. I keep forgetting that I don't need to move it back, but I always do that. It's out of habit. I want to move in the Z direction, and then we're going to do a remap numbers. I don't know why every time I'm about to record, I always have to clear my throat. It's really annoying. Obviously, I talk a lot. So after you do remap numbers, just do the usual construct domain. Plug this in here, and do bounds. And then instead of closest point, oh, well, not that, closest point, we're actually going to use distance instead. But before we plug these in, We're actually in between these is going to be a graph mapper. We're actually going to utilize the graph mapper today since it will help us out determine the intensity of the point that we want, or not the point, intensity of the manipulation of the points. And you'll see what I mean in a second. So you just plug this in, and we just plug these two values in here, and then look like that. We're going to now, if we go to a panel, throw a panel on here, so you can see it has their own branches. So we want to flatten that so it doesn't redo the same command every time. So we're going to do a flatten here, and we're going to plug this into A. And then we're going to type in point into here. Oh, not point line, do point. And now we're going to know that it's about here, so I'd say around, let me look at that picture again, somewhere here. So I'm just going to guesstimate exactly where it's at. So I go to point, have my point, and I'm going to set my point, set 1 point, sweet. And now all I have to do is use this flattened point geometry. And actually, I'm going to hide this because I don't need it. And then plug it into geometry. And we'll see what it does. Alright, so it looks like nothing is happening. Alright, that's, oh well. Okay, it's lifted up a tiny bit. There is some difference, but there is no graph. So that's already a problem. And we're going to use the Gaussian graph because that's kind of the articulation that's happening here. It has that little kind of hump going on here, or hill. I don't know how else to call it. So it is working because there is 1 point moving. Right now it's at a 1-to-1 scale, so of course it's not going to move only but 1 point. So 10, 10. Let's just try 10 and see how that works out. And 10 seems to be pretty nice. I think 10 is a good number for these things. Oh, I didn't do up. That's what I want to do. I want to do. So right now the domain is only up to 1 at this is highest. So I'm going to change that to to be 0. I'm just going to plug in 0 just for the sake of understanding that, and do a negative here because I want it to recess into that piece. And I'm going to do 7. Let's try that. Okay, so that's kind of the depth I want, but it's way too sharp. As you can see, it's kind of just, sorry, it just falls right into that kind of pit. And let's actually start to widen that out. Now let's go here and a little bit here. As you can see, in this one, it has it kind of going out. Of course, there is a little divot here, so I'm actually going to move it a little bit, and that's definitely something I'm looking for. Awesome. And a little more. Yeah, a little bit back. All right, cool. That's definitely something I'm looking for right here. And then, where's my image at? So I need that to kind of wind up. Okay, this is a pretty good start. I need this now to I want to expand it a little bit. I don't want it to be just 10, so I'm going to change it to 15 actually. 15. Let's widen that. It'll widen out a little bit, and now I can actually move it back a little bit. There we go, something like that. All right, cool. Because this is going to be the biggest type of articulation. Maybe not that wide. Huh. It looks pretty deep in here. I'm trying to make it somewhat accurate to this. So now once we have that, I'm going to actually create these 3 points. These 3 points are positive, kind of pushing up the points or pulling up the points instead of pushing down the points. And this seems to be good. All right, cool. So let's start with the next ones. All right, and you can actually, if you're learning, I'd recommend typing it all. So for the second one, I'm actually going to type it all instead of copying and pasting. But for the other 3 that are left, the other 3 that are left, I am going to copy and paste. So I'm going to redo that. I'm just going to do a move. I'm actually going to hide this because I know what it does. Hide. We'll just do Z direction because that's the direction we want in. We'll do a remap numbers. I'm just going to quickly go over it since we already went over it. Construct domain. bounds. We'll do not construct a main. What is it called? Graph mapper. Put these bad boys in. I always have a hard time grabbing onto these for some reason. We'll just expand this out. Well, not that much. Probably just like a little bit. And then we'll do a distance. And again, when we do the distance, we're going to use the exact point A is going to be the exact same. So whatever this point A is at is going to be on this flattened tree. And then we're going to do point. And now what we're going to do is we know that this is going to be 0 and this is going to be 7 or something like that. It doesn't have to be exactly 7. And we know the graph that we want is a type of Gaussian graph. So actually it's leaking onto my second screen. So Gaussian. And now we can do top. And I know it's somewhere around here. Let me turn this back on again actually. Yeah, it's somewhere around here. So I'm going to put that. And now I can see my point, and I'm going to right click, set one point, and now we have our point done. Alright, so all we have to do now is just plug this in. Nice. And as you can see, it is working to an extent. It's only moving that 1 point, which makes sense, or 2 points. It's not moving that much. So we can set this to 10 again. I'm actually going to set it to 10 instead of 15, like I've been doing. So let's try that out. Okay. Awesome. So now we can actually start to articulate these points now. Let me see what these look like. It's a very slight bump, so I'm going to definitely not make it this severe. I'm just going to move it around a little bit. Sorry, it's a little hard to see with all of these points here, so I'm just trying to maneuver around the easiest way to do this. That's a little high up. I don't want it that high. I want it really, really light, so I'm actually going to go over the boundaries and do like something like probably 25. Wait, what direction is this in? The X direction. I want it in the Y direction to be very subtle, so I'm going to actually do 25 on the Y direction. Let me change the other one too. Okay, that actually seems to work. Just very slight, but I'm also going to lower the count of the movement of the points to not be so high up. I just want it to be very subtle. Nothing too severe. There we go. Something like that. That seems to work out quite well. Alright. So now we have to do the next point. So we're going to do, we have 2 points done, and we need to do this one right here, and this one right here. So all I do is copy, Control C, V, and copy and paste this, and I'm going to delete that point. And I'm also going to copy and paste this one. And do a move. I'm just going to plug in a move to each one already, to the motion, move, and to the motion. Awesome, and I'm actually going to align these moves up if I can. Let me do that real quick. Boom. Awesome, now they're all aligned. You see the script is getting quite long, but it's not going to get much longer than this, I suppose not. So we'll type in point, and then we'll move this one here. And then all we're going to do now is just use probably here. I'm actually going to make it exactly parallel with this. So I'm actually going to do a move command in Rhino and line it up exactly with that. And then somewhere here. So we're going to start with this one. So where is my graph at? It is right here. And I'm actually not going to make it this all the way here, so I'm going to say this is not going to be 25, it's only going to be 10. You only need that much, you don't need large numbers. 10. Awesome. So now we have that type of kind of sharp geometry going on. I want it a little bit more severe actually. So I'm actually going to do something like that, but turn up the height, something like that. Yep. All right, and it should match something along the lines of that. Yep. All right. Cool. 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 All right, it's doing it quite well. Sorry if you hear all my click noise. This is just how I model. I know a lot of people don't like it, but that's the nature of modeling in general. So, and then this last point, I'm going to set one point here, and then kind of move this back here. Change this to, and now I only want this direction to be affected, which is the y direction, affected that much. So I'm going to keep that at 25, y direction at 25, but I'm going to go back and put this at 10. So only affect like an area, rectangular area. And now all we have to do is plug this in and hide this. Alright, and now we're going to do what we did with that other one and sort of flatten that out. But it seems to be a bit more severe than that from what I've seen. Yeah, like right here, it's very kind of bulged out. So I'm definitely changing the parameters of this to be a little bit bigger. Let's see if I can already set a parameter. Let me see if I can actually start to move this down. That actually sags it versus that. Maybe not that high. I'm actually going to use rational to get more of an kind of accurate way of doing it. Yep, that looks really good. All right, nice. I want to capture more of the 25, so let's say 50. Actually, how much is in the y direction? 40. Not this one. I need this to extend out a little bit more, but I think this is really good for what I have right now. Like, it's pretty accurate in terms of the shape of it and all that. So now that we have that done, so now we have the form with the amount of points done. So we start to manipulate the geometry by using points. Once you have that, we can actually start to make the poles. And the way to do that to create that checkered pattern is like we did in the brick wall, parametric brick wall. We can do a call pattern. Panel, double click, 1, 0, press OK, multi-line data, list, and hide this. And as you see, we have our checkered boarded list manipulation happening. So as you can see, if you don't understand what 1 and 0 is, you need to go back to a list manipulation tutorial. Not necessarily mine, but someone else's as well. I mean, if that helps you out. But if just a brief overview, 1 is true and 0 is false. So 1, 0, 1, 0. And the reason why if I explained earlier, I kept this at even number is because this needs to be even always, and so does y in order to create that checkered pattern. Because of the listing. If it lists in odd numbers, it'll just show lines of geometry, and I'll show you that right now, actually, if I can do this. Yep, alright, so 78, the reason why this is an even number, right, but 78 divided by 2 is 39, so as you can see, it creates an odd number here, so you have these lines instead. So we're going to do 80, awesome. And now we are going to Alright, so now that we have that, I'm actually going to move this in the Z direction, and I'm just going to plug in a slider into the Z. awesome. So now that we have that, we can actually start to manipulate the geometry on how it's moved. So I'm going to say all the way to 10. And that should be good. Sweet. Alright, once we have that, we're going to now go back to this coal pattern one and make circles now, which will serve as our metal poles. Now I go top view, you see that they're intersecting a little bit. Here they're intersecting. Ugh. Okay, let me think. If this reaches that, this reaches that perfectly. Let's try 0.5. Let's do rational up to 3. See how close we can get it without intersecting. Alright, that's pretty close. Alright, awesome. So we have that, and now we are also going to draw a line in between these two lines. So they will serve as our line. So we have our coal pattern, bottom. So this will be our start point versus our end point. And you can see we have an array of lines. Oh no. Alright, so now we have an array of lines. We can actually start to create the poles now, which we have with the circles. And we can actually use something we never used before in this tutorial, which will be the extrude along component. So this extrude along component is basically how we can show our points. So how we can extrude the exact distance of these lines. So these lines have a certain distance, right? It's exactly 10 feet actually, but it's 10 feet in a direction of these lines. So it's not starting from like a flat area. So it's not like attractor point based. The extrusions are not attractor point based. It's more of the movement of the points that are attractor point based. So knowing that, we are going to now go to circle, and we want to know it has base and curve. And the base is basically what you're trying to extrude, so we can actually go here and we can put what you are trying to extrude. And the curve is basically Alright, sorry about that, guys. My film cut out for some reason, and I didn't want to start all the way over on this one because I had all this already done, and I didn't want to redo the geometry since I already had it done here. But anyways, I was saying that base is basically what you're trying to extrude from, and the curve is the railing of how you extrude. So this is the line component, and the railing how you extrude versus the base on what you're trying to extrude here. So yeah, I apologize, guys. I don't know why my OBS is acting really funny right now. It just randomly cut off, and I have no idea why. I think I accidentally turned on my start and stop component of the record button, and I think it's like Shift R or something. Maybe I pressed that by accident. I'm not too sure. So yeah, I don't know why that happened, but anyways, all I did here was did the extrude along, and it created this. And then I have the cap holes here. So I capped the holes, and all I said now is I'm just going to bake this, so we're caught up to speed. So I baked it, and we're actually going to put this on a shaded view so we can see what's going on. Let it process the geometry. Alright, cool. And right now they're all grouped, so I don't have to worry about anything. Let me just move this out of the way and rotate this way. So yeah, that's what it looks like. It's just a bunch of obviously there's probably more geometry, but I don't think my computer could have handled it, so I decided not to do that. But yeah, that's pretty much it, guys. This is the parametric wall of wooden poles, and I will definitely put the files in the link in the description if you want that. So yeah, guys, let me pull it up real quick. So yeah, this is it. You see in comparison, it's a little different. You can also do this. It doesn't have to be exactly this, but it's definitely something that will help you out in the future in terms of like how you would extrude or make a wall that's parametric and things like that. So yeah, guys, just want to show you this. Thank you guys for watching. Hope you guys have a great day. And again, I apologize for the film just randomly stopping. I have no idea what happened to that. I don't know why it's doing that. But yeah, guys, thank you guys for watching. Hope you guys have a great day. Bye.